The next thing we're going to discuss about the DAX language is the row context and filter context. The row context defines each row in a table. You are able to perform DAX expressions if the row context is known. This is while referencing a single row or iterating through a series of rows. The easiest example is a computed column in the analysis services tabular model. Here you are creating a column in the table for each row that calculates a new value based on that row in the table in the model. Gross profit is a great example and is computed there on your screen. Here we had added a column to the tabular model that's sales amount minus total product cost. It is an iterative function if used as a measure. Like a measure that you create in a tabular model, you're using this iterator function like sum to grab each row value from a table while looping through the rows to sum up the total. The measure internet sales uses the sum of sales amount for each row in the internet sales table. So instead of being on a row for a calculated column, you are able with DAX to iterate through a table row by row in that row context and sum a value. If you're in a client tool and it's filtered or sliced by some other dimension attribute, you're still going to iterate through, but only for the intersection of those values. If no row reference is given and you use a function that looks at a row context, analysis services will return an error. The error mentions that there is no row context for the column, and in this example it is because we are not using a function to iterate through the table reference, just the column name. So we can't create a measure that just references sales amount. The reason we can't is because there is no row context for that sales amount. A measure is throughout the whole table, so since it's going to return more than one row, you have to provide some aggregate function or other DAX function that can accumulate the values in that column or make decisions on that column. The filter context is an intersection of slicers to produce a measure or calculated value. This example shows the internet sales filtered by customer, the gender male, and the product category bikes. So we're actually using the evaluate and row function to look at each row in internet sales and calculate the internet sales based on the filters bike and male. If you notice, we didn't use filter here, but we actually used calculate, which is providing the filter for us. If in a query, you can use calculate or calculate table functions. They're sort of equivalent to the filter function. There can be more than one filter for a filter context. It can also be defined by the user interface like Excel's pivot table. When you use the pivot table in Excel, the intersection of the row and column attribute produces a filter context of each row. So if you had a heading like year and a row like category, the cell, which is the intersection, has a filter context of, say, bike in year 2011. No matter what you do, if there is a filter or not, a filter context is always being used on all DAX expressions. If there are no filters, the filter context is the whole table. So let's talk about the use of filters and other DAX functions. To iterate on rows in the many side of a relationship, you would use the related table function. If you want to reference a column from the one side of the relationship, you use the related function. This is like what we did with the product table, which was related to the subcategory table. We were able to grab the subcategory name because it is related through the relationship between product and product category, and actually place that as a column inside a computed column inside the product table. If two or more filters are used in a calculate or calculate table function, it is using AND for the filter. So all rows have to satisfy both filters to be returned. Filters apply to a table or propagated to related tables. For instance, if the filter is product category bikes, only the sales for products in the internet sales that are of the type category bike are returned. Let's look at the demonstration of the row and filter context. First, we'll launch SQL Server Management Studio. Once that's open, we'll go ahead and connect to our tabular instance and drill into the database that we're going to query. I'm going to open up a previously created set of queries and just review what we did in the previous demonstration. Here, the evaluate function is the start of the DAX, and we're summarizing table internet sales with a group by, a full name, and then a measure sum of sales, which is the sum of the sales amount column, which we get a nice table produced from that. Next, we're going to look at the evaluate a little bit further and the add columns. Here, we're going to add a column to that internet sales table. It is called GPM% or gross profit margin ratio. It is a calculation of the sales amount minus total product cost divided by sales amount. When we run this, we see an additional column added to the internet sales fact table called GPM%. This is an example of the row context because the new column is added to each row of the internet sales table. Let's close that and not save that file and open up another file that looks at filtering. Now we'll look at a filter context rather than a row context. I'm going to reconstruct the next query by evaluating and summarizing the customer table. And all I'm going to do is reference customer, which is the table, and it should be with a single quote. And then I'm going to grab full name and gender for that summarize. So basically what I'm doing here is just querying the customer table and looking at the two columns, gender and full name. I have one extra comma there, and there's my summarize. Now, if I wanted to filter that table, I can actually replace the customer table, which is actually a filter context. Remember, anytime you reference a table, no matter if there's a filter or not, it is a filter context. So here, I'm basically going to say filter the customer table, and I'm going to use gender equals ILM. Now I've replaced that customer table with a filter context on gender equals ILM. And now I should get just the males. Got to use a double quote here and not a single quote. When I use a single quote, it thinks I'm referencing a table. So there's my list of customers filtered by just gender equals ILM. Next, I can add at the end of that query a new column. And that is going to be our sum of sales. So now I see the customer table filtered by gender male, listing the full name and gender as columns, and since it's a summarize, it's doing a group by, and then a new column for the filter context, which is a measure called sum of sales, and that's the sum of the internet sales amount column. You see how we easily reconstructed this summarize and filter just to show you more about what a filter context is. Now let's get to a more complicated one, and we'll start the same way. We'll evaluate, summarize, and here we'll do the product table with product category and product subcategory. Same thing that we just saw before. Need a comma and a close parentheses. And there's our summarize. So now we have a summary of category and subcategory from the product table. Next, we're going to add a new column to it. So basically what we need to do is before the summarize, say add columns, and I'm going to space some of this out just so we can see it. And then after the summarize of that particular filter context, which in this case is product, displaying only those two columns, we're going to create a new column. And here I'm going to copy and paste what was already created. Here's our new column, and I should just be able to close the add columns and get the same results. So now I'm getting the internet sales summed based on category and subcategory. Lastly, we want to apply a filter to this. You can use the calculate table to calculate what we've just created to actually filter down to some other level. So here, as we space everything out, we can add filters. And in this case, we're going to filter by calendar year 2012. Close that calculate table. Oops, we need one more. Actually, I have it in the wrong spot. We'll highlight that. Now we're filtering for just the year 2012. Now, to get rid of that blank area here, we're going to add another filter for product. So now with this calculate table and the filter context, now you can see we're filtering by date, calendar year, and product category. Now we've cleaned this up a little more, and it looks pretty nice. Except for the fact that we're seeing internet sales that are blank. Remember, the relationship is always left outer join. So if there are no sales or fact measures, then it's going to display a null value. So let's scroll down in our queries and let's look if we add something. Intuitively, it seems like we could add this calculate for the sum that we're creating to the filter. But we get an error saying that it's not being used as a true-false expression. So let's try something else. And instead, we're going to add a filter to that calculate table that actually looks at that calculated value. Now, we can say if it's greater than 0, go ahead and display it. Or maybe in the case, we'll say greater than 100. And now we've applied a filter to the calculate table. To make it even easier, and since we're duplicating that calculation, we can actually define a measure called internet sales as a calculated sum of sales amount from the internet table and replace this guy with the measure as well as this one. And then it looks a little bit cleaner. That's a demonstration of row context and filter context. And as you can see, calculate table as well as filter can be used when filtering tables of calculated values. Now let's talk a little bit more about functions you're able to use in the DAX language. There are many functions used in DAX and more are created with each new release. Here, we're going to cover some of the most used functions while writing DAX queries, measures, or computed columns. The first is error handling, and it is the most common for unexpected values in calculations. The A and X suffix functions are aggregates like count or sum that can function on a filter context and use related tables and their columns for calculations. Time intelligence is most used in the model itself for calculations and comparisons, and this is one of the most powerful parts of the DAX language. Lastly, in this section, we're just going to cover some other functions that are useful but don't fall into any specific category. For error handling, the first one we'll look at is if error. The most common used function to trap errors is if error. This function enables you to check for an error and use the expression in one part of the function. The second part lets you replace the error with an expression, and in this example we replace it with blank. Blank is null and is not an empty space. It acts like the null value in T-SQL, and remember, it's not an empty quote for text values or 0 for numeric. The value does not exist and does not produce an error if used in other calculations. If used in other calculations, it's either a blank or doesn't affect the calculation at all. You can use the if function with the isError function to do the same comparison, except you have to repeat the expression in the else part of the function. That's why it's better to use the if error. And in this example, you see if with the parentheses and then isError. It checks the calculation first, then replaces it with a blank, else you have to repeat the calculation again. So in the upper right, you see the more efficient use of the if error. Now let's look at the A and X suffix aggregations. The first one is count A, which is the most useful of the A suffix functions. Here you are counting rows with a criteria in the function if the values are not empty. If there are empty values, you can actually use count blank to find the remainder of the count. And if you want to count all rows, use the count rows function. This brings us to the distinct count, which will count distinct rows for the values in the column specified for that function. The F suffix is used with something like the sum aggregation. It allows greater flexibility in this aggregation. You can pass a table or filter context to the function as the first parameter. Remember, when you pass a table, it is a filter context. The next can be a reference from the table or an expression. The expression can contain a related table column as part of this expression to be aggregated. You can see in this example, we're multiplying from the Internet Sales Order Quantity column times the related standard cost in the product column. This related column cannot be used in the sum aggregation, and that's why you have to use SUMX. You also do not need a computed column to get the related tables column. Remember, when you use a computed column, it actually calculates that and places it in memory, whereas if you create a measure, until you reference the measure, it doesn't require any memory. Other useful X suffix aggregations are the average X, count AX, and min and max X. So now let's look at a demonstration of some of these other functions. First, we're going to launch SQL Server Management Studio from an icon on our desktop. It will prompt us for the instance we want to use, and we're going to take the default at this time. We're going to drill into database and create a new query at the AdventureWorks DW14 database. I'm going to bring up a previously created set of scripts. The first one we'll look at is the if error. So here we have an evaluate that does a summarize on a filter context of customer where we're looking at gender equals M. Since it's summarized, we're grouping by the customer full name and gender. And then we're creating a new calculated column. And in this calculated column, we are summing the internet sales amount minus the product cost, which will give us our gross profit. Then next we divide it by the sum of the internet sales amount. Now, if there's an error in the internet sales amount, like a null value or 0, this calculation will return an error. But since we're wrapping it in the if error, we can say as part of the else, if it returns an error, put a blank, else do the calculation. I'm going to go ahead and run that, and you should see the results of the gross profit margin for full name of customer and gender, and then their individual profit margin. Now the alternative is to use the if statement with the is error, but you have to repeat the calculation twice in the function, and that is why we use the if error instead of if with is error. But just so you know that those two are available, you can use those in different types of functions. Next, we're going to open up the count A script and take a look at it. Here, I'm going to copy this one that runs properly and paste it above. Here, we're evaluating and summarizing using a filter context of gender equals male. I'm going to remove the or of the customer is female just so we get the males. Then we're grouping by gender. But since we're going to count with English occupation, I'm going to change the gender to English occupation. And next, I'm going to take the A off the count. And here, if we try to run this, we will see an error that the count function needs other types of arguments. If we use the count A, then we'll see that it's able to cross over between the customer gender and English occupation and give us the correct count. And here we see the row count of customers that have professional as their occupation, management, skilled manual, or others, and we get their row counts. The last one we're going to look at is the sum x. This is the x suffix, and again, I'm going to copy this and paste it above just so we can see the error if we use sum. Because we're using a related column, it is telling us we have too many arguments passed to the sum. But in order to get the standard cost, we're going to have to reference the table or filter context that has the relationship to the product standard cost. And by making this a sum x calculation instead of a sum, we're able to use that related. So here you see our filter context is just male customers, but I mean if we wanted to, we could just say customer here. And then we could group by full name, gender, and then sum the total cost, which we'll label as column internet sales, and we'll multiply the order quantity times the standard cost in the product table. And we're able to cross the product table because of the relationships. Now we get a list of a customer full name, their gender, and the cost of sales.